Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the mapping of SQL to XML so that we can store the data in a query language manner while having all the features included of the XML. As we know that XML is very popular among web designing and web interface handling, but we know that the database requires some querying language. But the DOM provides the proper language on the parsing, but it does not provide the declaring of the querying part. Now, to handle this one, we need SQL to perform on the database while having the XML features to be embedded into the web interface. Now, how to do that? We should include SQL as a part of the XML. There should be a mapping from the XML to SQL and SQL to XML in a vice versa nature. Now we will see that how SQL can be implemented in XML with the help of a declarative querying language and uses XML's own verifying dataset in the SQL so that SQL can be performed by its own nature using the dataset of the XML. So now we will solve a multiple query and based on therefore XML data to see that how SQL mapped on the XML data. Now let us look at this one. We know that other than using the department of the university, which are both an XML document, we are using row as a new SQL part that is embedded in the XML document. That means each of the data that we are storing, like the department name, the instructor, and all the relation inside this department element will be stored of the tuple including the SQL command row. Now row is given that not every time you have to define the department element for storing the tuple. We can just open it once, have the rows defined one by one, and then close it just like a normal XML document. Now that we have finished one row, we should close the tag row by the SQL part and then again start a row if we want to insert one more tuple into this element. So we can do that just by inserting another row. We will add another tuple to our department element in an XML. Now that we have added the two tuple to our department element, we should close the department tag here and go for the next element. So we will add another element course in our university details and we will then follow the row rule in the course element too. So we have a course ID, the department name as a foreign key constraint to our department relation and the credits with the course. See here the department name tag of this course element should be matched with this department that we have just previously discussed and the department name of that element department. Now that we have finished one row, again we will close this row and then start the next row if we want to insert another tuple to the course relation. So we have added two tuples and two set of information to the course element. Now we should close this course element as well as the main or root tag that is university. Now here we can see that we have used most XML documents for designing purpose and use the row element or the row tag inside the XML one. Now when we want to fetch a query out of this database, then we will use the SQL syntax embedded with the XML element and attribute. Now, if I want to select the following table that we have already said in this XML document schema, we can do this in the XML and in SQL too using the XML attribute function to create the attributes to a particular relation or element and create the XML element function to create an element followed by that in which of the particular elements that we want to add. So if the using of these two elements, then we can join this using the XML element function. So now let us do this one within SQL. Here we are creating an element course with an SQL query. We are writing select the function XML element followed by the keyword name, then the name of the particular element, that is course. Now we will create the attributes inside an element. Obviously, we know that attributes are always attached to the elements. So first we need to create the element, and then inside it we will create the attributes. For creating the attributes, we will refer to the XML attribute function. Now here we can see that we can using the XML attributes function to create the attributes and hence refer to the actual values that we have designed in the XML document inside the SQL and refer to them. So we are creating the CID, that means the course ID, as the course ID. Now as course ID just refers to the XML document that we have created. Same like the department name as department name, that means the department name of the department relation that we are taking as a foreign key constraint, because department name as department name is the referring to the XML document. Now even we can create a sub element inside an XML element, that when we have started defining an XML element, if inside that element we are creating another element, that means it will be a sub element to the parent element. So now I will create the XML element title as well as XML element credit to this course relation, so that we can refer to that CID and department name are the attributes of course that will appear as a property to the course, and credit being an element to the course. That means we can refer to all the element properties of XML for the credit, but not for the course ID and department name of the course. Here I'm creating a sub element with the keyword name followed by the name to it, that is title, and with the attribute title. See here, I am using the XML attributes for CID as CID and department name as department name because we are joining two relations. If they are belonging to only one relation, then we can just write the attribute name to the relation. Now from the course that we have created inside the XML, we are creating all this one. Now, XML forest is another collection that we can use in the place of XML element and attribute. The XML forest is also used for just like the XML attributes, but the same difference is that XML attributes create a collection of attributes for a collection and an element, whereas the XML forest creates a collection of sub-elements to an element. So the main difference it is creating an element, and the XML attributes created an particular attribute. So when there are more than one elements to a course or any other element, then we can say we will use the XML forest, not the XML attributes function. Now XML ag or XML aggregation is a function or an aggregation function that we can use for an XML document in SQL, so that we can create a collection of sub-elements or collection of forest for which the XML element is applied. That means if we are referring to a particular XML element, then the aggregation will be based on that particular XML element. Say we want to create the course relation on a sub-element basis, use the course ID as the department wise or the course wise. So we will use the course ID for the XML ag function, which will group by this a course ID of a course relation or element. Now let us see the solve the query. First, we are creating an element that is name is department, and the attribute it will get is the department name. Now we will create with an XML forest and XML ag, that is a collection of the sub-elements. How can we do that? First, that the basic and unit function is XML forest, and on the basic of the XML forest, we will use the XML ag to generate an aggregate function on the XML forest that we have created. So in the inner part, we will have the XML forest, and in the outer part, we will have XML ag. See the use that I am creating a forest course ID, that means a sub-element force ID based on the CID of the course, and then we are using the XML ag that is ordering by the CID. So aggregate function can be ordering, grouping, and everything. So we are using CID for that. Now we will select the from course element. Now that our query is we want the codes from department wise, we can use that group by department because our element is basically department, which is hearing a sub element from the relation codes, which is used by this codes ID as the XML forest and ordered by the codes ID function. See, the group by field should include all the attributes or from any of the attributes that is defined in this particular element name, not involved in the forest or XML attribute or sub-element's name. So in this way, we can use the SQL that is embedding the functions or features of XML by this XML element attribute and use the same one of joining two tables and having the tables and the elements as the attributes and a forest or a collection of sub-elements. So this is all for today. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.